This is Keep This Coupon, and today we're going to be trying some photogrammetry outside. So basically what this is it's a technique that lets us make 3D models of most kinds of objects. And the way it works is instead of like 3D modeling it in software, what we do is we take pictures around an object, like if it was the microphone, we take pictures going around in a circle around this microphone and use that information to stitch it together into a 3D model. Well, how can you make a 3D model out of 2D pictures? Okay, well, this is basically what your eyes do. So you have two eyes, most of us, and they're a bit apart, and each one is grabbing 2D data. But then what your brain does is it processes them together. You have two pieces of 2D data, and then you see what is pretty much a 3D image. So here you have two cameras, and when we go around an object, we're going to get a bunch of cameras, essentially. So we want to take a bunch of photos around an object. Ideally, that object does not change, so it's not shiny, such that its reflection looks different from every angle. We want it to look the same from every angle we take it from to not confuse the software. We want it to be kind of lit the same way. So if you have light that's going over it and the shadows are changing, that's no good. We want consistency in lighting, reflections, and the object shouldn't be moving itself. So you can probably get, a 3D model of the base of a tree, but then as you go further up, it gets a little bit too detailed and the leaves and stuff can move and the shadows move too. So we're just going to be out here and testing out a bunch of different objects like people, I don't know, some random objects, some scenery too, and we'll see what we can get. So what we've done is we've taken a bunch of video going around the base of a tree, and this should be a good 3D model because it's in the shade, so the lighting isn't changing. It has a lot of texture as an object. You can see there's a lot of detail in the ground and in the bark itself, and obviously the object has no reflections and it's not moving. It's rooted in the ground. So what we've done is we've taken video of us going around it instead of taking pictures, because what we can do is just take frames from that video and have that be our pictures. So when you look at the video, it's way too long. We only need like 100 pictures max. So what I've done is I've sped up the footage. So this is basically sped up footage, so we get only like every 10th frame or something like that is what we're going to export. And what we want to do is turn this into an image sequence. So we basically turned this sped up video into a bunch of frames. So it kind of looks like we took 100 pictures going around the tree. And then what we're going to do is going to import this into our software. So all I'm going to do is I'm going to export this as a JPEG sequence, or you can do a PNG sequence. And then we're just going to import it into the program. Okay, so now we have exported all our frames, and we have this image sequence over here, which is just a bunch of JPEG images. And what we're going to do is we're just going to import this into the program. We're going to be using Agisoft Photoscan. There's a bunch of programs, some of which are free, that let you do this photogrammetry. So we have these images. We're going to import this, and it shouldn't take too long. And now we have all our images down here. And then the first step is you basically go through the workflow. So the first step is going to be called align photos. What this means is it's going to be calculating a virtual representation of where our cameras were. So what we expect is it's going to position the cameras in something that looks like a circle. So it's going to use that difference in images to figure out where all the cameras were in the first place. So what we're going to do is we're going to click align photos, and you can choose how long you want this to take. The difference between low, medium, high, and highest is like 20 minutes apiece sometimes. So make sure you pick something that has high detail but doesn't take up the whole day. So in this case, since we only have like 100 something images, we're going to choose medium, and that should be fine. So we're going to choose medium, and then this should take a while. It's going to give you an estimate, and then we'll be right back when that's done. So it is done aligning the photos, and you can see our result. We basically have all these blue looking squares, and each one of these represents a camera. And as you would expect, they look like they're in a circle pretty much. And then we also have what's called a sparse point cloud. That means it doesn't have that many points really, but you can already tell it's looking like the base of the tree, so it's working out okay. But then of course we also have a bunch of outliers, points that we don't want, especially when you zoom out. You have stuff that's way out over here, and we're going to take care of that. But basically the next step is, let me just disable these cameras. The next step is making a dense point cloud, so you can really see what the textures look like, what this whole tree is going to be. So we're going to turn this 26,000 points into maybe a couple million points, we're going to see. So far it's looking good, so we're just going to go to workflow, build dense cloud, and then again we're going to do medium. High is going to give usually a better result, but it takes maybe an extra 30 minutes this time. So it's not really worth it to me. So I'm going to choose medium, and then it's just going to calculate a dense cloud, and then it should have something like 1 million or 2 million points. Okay, so we have generated our dense point cloud, and it looks like this. You can tell that it almost already looks like a completed model. So we have 1.5 million points, and as you zoom in, you can see that this is made out of points, but it's so detailed that this is actually a very, very good result. And this is the difference between our aligned photos, sparse point cloud, and our dense point cloud at medium quality. So we got the base of the tree and also a good region of ground around it. But then we also have a bunch of points that are kind of floating, and these are basically errors that we need to account for. So the software can't see everything. So basically what we're going to do with these kinds of points is we're just going to highlight them. So for example, this chunk over here, we highlight and then just press delete. And then we just do this until we're satisfied, and then we're just going to triangulate the mesh. So let me just do this 1 or 2 more times. So again, you're just going to take these points that you can tell as a human looking at this. The software can't always tell that these are errors. So let's just get the last chunk out of here and delete. And there we go. And you can spend a lot of time going through this, getting it to your satisfaction. But this is good enough for me, even though, well, let's just do one more actually. Okay, now it's good enough for me. So what we're going to do is now we are going to build a mesh. So again, we have a point cloud. This is not really a 3D model. It's a bunch of points with position and color values. What we need to do is triangulate the mesh. So any 3 points near each other are going to form a triangle, and it's going to inherit the color of the average of the 3 points. So we're going to go to Workflow, Build Mesh, and then here we get a couple different options. We can choose, first of all, the type of surface, but most importantly, we can choose how many polygons or tries we really want. So it's going to indicate what a medium and high level is, and I'm just going to go for 100,000 triangles. And then you just click OK, and then it's going to chug along and do that. Okay, so we finished generating our 3D mesh. So again, this is our dense point cloud, and here is the 3D model, which is really just a surface embedded in 3 space. Well, you might look at this and say, well, this looks like an absolute downgrade. We had so much detail in the dense point cloud. It looked real. But then when we go to this mesh, it kind of looks blurry and not so good anymore. Well, what we need to do is do 2 things to make it look photorealistic again. So the first thing we're going to do is this is a bit bumpier than the ground actually is. So what we're going to do is we're going to smooth this out. So we're going to go to Tools, Mesh, and then we're just going to smooth it and just do 2 or 3 passes like that. Okay, so it's already smoother, and now what we want to do is give this thing a realistic texture. So the mesh, the actual geometry of it's good. Now we want to build the texture. So we're going to go to Workflow, Build Texture, and then you choose, in this case, I'm going to do a 4096 by 4096 texture image. And again, with these photogrammetry models, the UVs aren't the cleanest, but you can still get a really realistic result. So these are the settings I'm going to choose with color correction, and then I'm going to let that chug along, and we'll see the results in just a sec. So we have built our textures, and at this point we're done. We can export it, we can do whatever we want with this model, but look at this detail. This is a crazy, crazy good result, and we only use medium settings again. So this is actually very surprising that we got such a good result. This looks photorealistic, absolutely. And just so you see the difference between, this texturing and what we had at first. So this is the original texture, right? It's super blurry. It kind of looks like a super old video game from like the 2000s, early 2000s. And then here, which will take a second to load because it's very detailed, is going to be the new texture. So this is absolutely photorealistic, and basically you use the same process to do all sorts of models. So with other stuff, you're going to have to delete more points from the dense point cloud or maybe do some green screen work, etc. But basically, this is the final result. And what you can do is you can export this. You can export model or just the point cloud. For the model, you get the OBJ file and also the texture itself. And yeah, so this is how you do photogrammetry. You basically find your object under the right conditions. You take a video and extract those frames, or just take pictures, which is sometimes the easier way to go. And then you bring it into the software, go down the pipeline, and then hopefully you have a nice model. Sometimes you need to do a bit of cleanup in a 3D package like 3ds Max, Maya, Cinema 4D, whatever it might be. So I'm just going to show you some of the results that we got outside of this, or also including this, and thanks for watching.